Let's go over Activity 1 and talk a little bit about the first homework as well. So after you've downloaded the activity1.rmd file and then also the data files into your BAS320 folder, you'll open up the RMD document and you'll want to make some changes right off the bat. Namely, you'll always want to put in what section that you are currently in and then also your name. So I'm going to name myself just Solutions and I'm going to leave the section as both of them right here. So for this particular assignment, what you'll notice is that you will be working with equations, and the equations as written in this document look a little bit funny and hard to really tell, what the equation actually looks like. That's just the way that you get equations into this sort of document. You won't be writing any equations this semester. But to see what they actually look like, clicking the knit HTML will let you see kind of what the final form is. And so this way, when you're working through the activity, you can see what equation you're supposed to be working from. All right, so some directions for this. You want to make sure that the activity1.rmd file is actually in your BAS320 folder and that you're currently looking in that folder for the data files. So how can you tell what folder R is currently looking in? Well, in the console window in the upper left, you'll see a path that describes where R is currently looking for files. And right now, I don't have it set to the BAS320 folder. You will have set the BAS320 folder as the default, so it should always read that. But in case it doesn't, you can always go to Session, Set Working Directory, and then choose the directory to be your BAS320 folder. So for me, I'm going to navigate actually to a special folder, since I keep everything separate, Activity 1 here. And so I see there's the data file, there's the RMD file, so I'm good to go here. Okay. So another thing that you're going to be worried about with all assignments, all RMD files, is how to put your R code in correctly into the document so that it gets compiled. So an R chunk is denoted by a set of 3 backquotes, then a curly bracket, an R, a space, and then potentially a name for that code chunk. I'm going to try my best to name the code chunk question 1, question 2a, etc. And the second part of the R chunk is this line with 3 additional backquotes. Everything in the middle is going to be put inside your final document, and not only that, it will actually run that code and put the results in the document as well. That's one of the strengths about the markdown language. So if you try to knit and you get some sort of error, very often that error is because you might have accidentally deleted one of these 3 backquotes here on the first line or this last line. All right, another thing about the assignments is that whenever you see a comment, that means that I'm expecting some sort of response. So on the activities, this doesn't matter too much, but on homeworks, if you do see a comment, you want to make sure to actually say something, like what we do here. If there's no comment for a particular part, that means you don't have to say anything. It's just all about the R code. All right, so let's dive into this activity. Question 1 just has us using R as a calculator, essentially. And so using the left arrow symbol, what we're going to do is we're going to define a variable called x to be 1/2 and then do some computations here. So remember the way that we define a variable to be equal to some number is with this left-hand arrow symbol. It's actually 2 symbols, the left-hand or the less than symbol and then a dash. And this is the way the left-hand arrow shortcut works. We basically give the variable a name. In this case, I'm just naming it x. Put in that left arrow symbol, and then on the right of that, we just put in what we want x to equal to. And in this case, x is equal to 1/2. All this code has been written for you here. So what I'm going to do is I'm going to delete all of these things that start with hashtags. These are just comments that you can put in that annotate your code and make it a little bit more readable. But in this case, we're not going to worry about that. Making sure those backquotes are there up on the top and on the bottom. And if I want to actually run this R code so that I can, complete the assignment, one thing I need to make sure to do is either have my cursor somewhere on the line that I want to run and click on this run up here or Control Enter. You'll notice that command gets sent down here and processed, and we see x is now equal to 1/2 in the Environment tab. All right, so question A wants us to evaluate this expression. What does that expression look like again? Well, that's the quantity x squared over x minus 1. So how are we going to do this? Well, let's delete these 3 comments and write the R code in here. So to take x squared, we take x and then the Shift 6 key, the caret sign, x squared. And if we want to divide by x minus 1, where did it go? Let me recompile it. I'm looking at some gaming websites right now. That's what that is all about. There it is. If we want to take x squared and divide by the quantity x minus 1, we want to make sure to put in parentheses around the x minus 1 because r respects the order of operations. So does this expression evaluate correctly? Yes, it does. It does equal to minus 0.5, so I know I did that right. What are some errors that might result? Well, very often what ends up happening is you forget to actually close off a parenthesis. So one thing you'll notice is that it's missing the right parenthesis here. If I try to run this line, you'll notice that it starts to become a plus sign. And in fact, no matter what I do after this, it either is going to result in an error or it's going to continue to ask, hey, what's some additional thing you want it to do? So if you get trapped in a whole bunch of pluses or if you get an error after trying to press enter, that probably means, hey, you've forgotten off a parenthesis. One nice thing about RStudio is that when you close off a parenthesis, it highlights the other one that it's matching. So we know that we got that right. So we're good. We can knit this. And we see that the code is in the document and then also the result of running that code. Awesome. All right, so for part B, a more complicated expression. For part B, let's see what the expression looks like. It is e raised to the quantity minus 0.7 plus 1.2x divided by 1 plus e raised to that same quantity. All right, so let us get this set up. Taking e and raising it to a quantity means that we need to actually use the function exp. We can't do e caret. That doesn't going to work here. And then minus 0.7, that's what we're raising e to, plus 1.2 times x. You'll notice that in the equation, there's no multiplication symbol between the 1.2 and the x, but r actually needs to have it there. Otherwise, it's going to come up with an error. Notice that if I left off that multiplication symbol and just clicked run, it would say unexpected symbol here. It actually needs to have that multiplication symbol to actually run something. So we take e raised to that power and divide that by 1 plus e raised to the same power. So since we have an expression in the denominator, we're going to make sure to have parentheses. And to save ourselves time, I'm just going to copy and paste this. One thing you'll notice also is that if you do forget a parenthesis, very often a red X will appear on the line that you're working on. And that means that it knows that, hey, this line isn't going to run as is. And so in this case, I need to close off that parenthesis. That X goes away, and we should be good to go here. So I'll click run, and indeed, it equals the number that I want it to. So knit it, make sure it is inside the document. Looks good. It's good practice to always knit after putting in additional commands. You don't want to put in a whole bunch of R code, then try to knit it and then have it fail because it won't really point out where that error is all that appropriately. So you want to knit it as you go along so that you can catch any errors if they exist. All right, part C wants you to look at the log base 10 of the absolute value of the natural log of x. All right, so the reason why that's there is that r refers to the natural log as just log, and the log base 10 as log 10, so just a little bit of practice here. Basically, we need to take the log base 10 of the expression, the absolute value of the natural log of x. The absolute value is abs, that function, so inside that parentheses, I need log x. So you'll notice that I can put as many spaces actually wherever I want, and I can do this to make things clear or less clear depending on what my goal is here. But I've reproduced the expression and we can run it, and indeed it works out to be what we want it to. All right, so that's question 1. We'll knit that to make sure that we got that all set up. And now let's move on to question 2, which is going to have us deal with data here. So question 2 wants us to look at act1-customertrans.dat and talk about this customer's transaction habits. So the first thing we're going to do is we're going to import the file and name the data frame cust in all caps. My convention is to name data frames in all caps, so you'll be seeing that a lot this semester. And we're going to do this using read.csv. So how do we do this? Well, I'm going to remove these hashtags. And I'm going to remove the hashtag in front of the command that I've actually already written for you. But the way that we read in the data file is to give it a name, in this case, cust in all caps, left arrow symbol, because we're saving something into the variable, in this case, data frame cust. And the way we get in the data is to do read.csv. That's how we're going to read in a comma delimited file. And then in the parentheses, we're going to put double quotes because we're dealing with a file name, a text expression, and then the name of the file. And so assuming that this file is actually in the same folder that the .rmd file is in your BAS320 folder, then it should read in. So I'll click run, no errors whatsoever. What if I was in the wrong folder? Let me actually go and change this working directory into a different folder here. So you'll notice that I'm not in my BAS320 folder where all the data files are. I'm in a different folder. If I were to try to read this in, it would come up with an error that says, oh, cannot open file, no such file or directory. That just means that R is currently looking in the wrong place. So that's why I want to go back to wherever my BAS320 folder is. In this case, I'm a little bit more specific. I put it in the Activity1 folder here. So all right, run it, and we see that it is showing up in the Environment tab. We have a little over 1,500 observations with 10 variables. All right, so what Part A wants us to finish off with is to determine the number of rows and columns in the data set, not just by looking over here, but actually by using some additional commands. So if I do nrow, and then as the argument put in the name of the data frame, that actually gives me the number of rows, 1551. If I do ncall and the name of the data frame, that gives me the number of columns, the number of variables. Or I can get both of those at the same time if I do dim, shortcut for dimension essentially. Dimcust gives me the number of rows followed by the number of columns. So same information, a whole bunch of different places, just so you're aware of those functions here. All right, show row 27 of the data to the screen. All right, so how do we actually see what's inside this data frame? Well, in order to extract a particular element or a particular row or column, we need to specify the name of the data frame and then use square brackets. Square brackets allow us to refer to a particular position inside that data frame, and in general, it requires two numbers. We need a row number and we need a column number. So whatever number comes before the comma is going to be the row number. Whatever number is after the comma is going to be the column number. And in this case, we just want row 27, so we're going to leave the column number blank, and that's going to make all of the columns appear. Okay, so if we want row 27, then cust bracket 27 comma blank is what we want, and there we go. What is the amount spent for this transaction? Well, what we see is that the amount spent is $95. So $95, that would be our answer. And I can delete the rest of that stuff. What is the column name and number that contains the customer zip code? All right, I have a hint about looking at a slide. There are a few ways to go about doing this. The first one is to actually count, basically, well, where is the customer zip code? CZIP here. Its name, obviously, is CZIP, and that is the first, second, third, fourth, fifth, sixth column. So, okay, I know that's what the answer is going to be. So it's CZIP, sixth column. What's another way of getting that information? Well, this arrow right here gives me a preview of what's inside that data frame. It gives me all the columns. So once again, 1, 2, 3, 4, 5, 6 is CZIP. And I could also get it by using my hint right here. If I combine data.frame and in parentheses put in names, and inside another set of parentheses put in the name of my data frame, that'll actually give me all of the column names and then also the column numbers as well. So we see that, yes, indeed, we're getting this question right. All right, Part D asks us to find how many times this person purchased something on the internet, basically the column internet. And once again, there's actually a lot of different ways to find out this information. The first thing we can do is actually just get a summary of the entirety of the data frame. And this will tell us something about every single column in the data frame here. So in this case, we're looking at the column internet, and we see that in total, 146 times this customer actually made a purchase on the internet. Now, this is a lot more information than what we really need, so we can be a little bit more specific. I'm going to hashtag that out so that when I compile this document, all of that output doesn't exist. Instead of referring to every column in the data frame, I can extract a particular column the internet column, by using a dollar sign. If I do cust dollar sign internet in all caps, notice it's kind of filling it in for me. I can either select that or type it out. If I do cust dollar sign internet, this refers to the very particular column in that data frame. So if I do summary cust dollar sign internet, that'll just give me the summary for that column. Actually, the same way of getting that information would be with table as well for just that column. Regardless of how I do it, I see that it looks like 146 times this person purchased something on the internet. All right, another column is the industry column, basically the what type of store the customer made the purchase from. And very often we'd like to get a visualization of the possible values and their frequencies. We'd like a bar chart. So how do we make a bar chart? Well, it's easy. The command is just plot here, and we need to tell it what column we want to be making a plot of. And to extract just the industry column, we'll type the name of the data frame cust dollar sign and then type out industry. And when we do this, it'll make a bar chart. And unfortunately, there are so many different categories here that it's difficult to tell, all right, which do all these categories actually refer to. That's just one of the drawbacks, using a bar chart to visualize something with so many different possibilities. It's going to be impossible to actually label every single possible category. So this isn't the most useful visualization, but hey, that's how you make a bar chart here. So if you wanted to see, which was the most common column, you could always do table to get a frequency table of industry and really just kind of scan up and down until you find the one that's the most common. We see based on the bar chart, it's going to be a number that is probably a little bit over 300 or maybe a little bit below 300. And my hunch is that it's actually going to be eating places at 290 here. How could I actually get a more definitive answer? Well, what's neat is that I can actually take the results of making that table and actually put that inside sort in parentheses. And that'll sort it from, by default, smallest to largest. So we see ones up here at the very beginning. And at the very end, I see that, oh, I was wrong. It wasn't eating places that was the most common. It was actually automotive fuel. So this person looks like they're spending most of their money on, this person, boring person, fuel, going out to eat for food, buying stuff at the grocery store, buying, aspirin at the drugstore chain, etc. So a pretty typical person here. Okay, so column distance here talks about how far away the customer is away from the store. And sometimes we see bogus values here. Sometimes we see negative values. So for instance, if we wanted to look at row 563, we could do cust, then square bracket 563, comma blank. That prints out the entirety of that row, and we see that this is one of those where the distance is minus 999 here. Basically, we just don't know how far away the customer lives from this storefront for whatever reason. So we might want to replace this bogus value. Maybe we actually know what this company corresponds to, and we know how far away that customer lives. Maybe it's 2 miles away. So how can we change this particular entry from a minus 999 to a 2? Well, we can use the left arrow shortcut like we did at the very beginning when we defined the variable x to be equal to 2. So what we need to do is we need to refer to this particular element of the table here, of the data frame, basically row 563 and column distance. And there are a few ways of actually doing this. So way number one would be to say cust 563, the row number, comma, and then the column number. And if we scan back a little while up here, we see that it's actually the 10th column, that is distance. So we could say cust square bracket 563, comma 10 is equal to 2. Another way of referring to that particular entry is by actually typing out the name of that column instead. So I don't know, immediately what position that column is in the data frame, but I know the name of it was distance, so if I put distance in double quotes, that'll do the same thing. So just to show you that that is actually working, let's look to see, yep, distance is equal to 2. If we redefine it, we see it's still equal to 2. And finally, one last way, and this is actually my favorite way, is to take the name of the data frame and put a dollar sign, and then type the name of the column here. Because basically, remember, data frame, dollar sign, column name extracts that one column, and then we can just refer to the position inside that column. which is the 563rd, since it belonged to row 563, and that's going to work as well. So this is way number 1, this is way number 2, and this is way 3. I'm going to say that's preferred because that's my favorite way here. All right, so we confirm that this works, and we're good to go and move on to the next question. All right, which is kind of addressing the fact that there are a lot of values of distance that are minus 999, which is just a standalone for an unknown distance. How many of those are there? Well, I could get a table of values inside the distance column, and I see that after I've made that one change, there's still 51 rows that have an unknown distance here. So maybe I'd like to replace that with something, or maybe just eliminate all those rows altogether. So in this case, I want to make a subset of the data that basically takes out those rows with unknown distances. All right, so we want to take a subset of the data. We're going to name it cust_d. That has only the two columns, amount and distance, where the distances are at least 0. All right, so what we're going to do is we're going to use the subset command to accomplish this. So since we're going to be saving the results of a command to something else, we're going to use the left arrow convention here. And the thing that I'm naming is cust_d, basically the customer database based on distance here. Just an arbitrary name that I came up with. And to do this, I'm going to use the subset command. And what the subset command does is the first argument is going to be the name of the data frame that I'm going to be taking the subset of, which is just cust. The second argument is the condition that the rows need to meet to actually be selected for that subset. So in this case, I only want to keep track of rows where the distance was at least 0. So I could say distance greater than or equal to 0. And if I want to keep all of the columns in this subset, then I would be done. In this case, I just want to keep track of the amount and the distance columns. So I'm going to say select equals, and then since I'm basically needing two columns, I'm going to treat these as a vector. C, and then in parentheses, double quotes, amount, comma, distance, both of those in quotes, will accomplish this for me. So there we go. There's cust_d now, 1500 observations, 2 variables. Click on that, and I see that, yep, just amount and distance here. And if I get a summary of this subset here, I see that indeed the minimum distance is 0. So I've succeeded. So I've done this. I've done that first part here. Now I'm being asked to figure out what the mean of the amount column is. So given the command right there, the command for mean is just mean. And I just want the amount column, so cust_d $amount, extracting the amount column from that data frame. $48.8. And what about a summary of the distance column? So there's a summary right there of both columns. If I just wanted a summary of the distance column, I could extract just that column with the name of the data frame $, and then the name of the column. All right, so there's a summary of how far away this customer is making purchases. The median value is just 3 miles away. The average value is 106 miles away. Now you got to think, all right, does this mean this customer is really driving far to make a lot of purchases? Well, no, that's not the case, because a lot of these purchases are internet purchases, and it doesn't matter how far away those stores are. Those large values of distance are skewing the value of the average towards larger amounts. So we're good. I can delete these last 2 hashtags. I can knit this. And kind of bad practice on my part, I should have been knitting all along to make sure I wasn't getting any errors as I was going through the analysis. But, I've done this for a while, so I was pretty confident here. All right, last question is optional. It is learning a little bit about how to make sequences of numbers. And so let me just go through this. What we want to do is we want to make a sequence called y, named y. That's going to be a sequence of numbers that goes from 8 to 13 in increments of 1.8. All right, so how do we do that? Well, since I'm going to name something y, I'll do y left arrow here. And to make a sequence, the command is seq. And then in parentheses, what I say is I give it a starting number, from equals to 8, an ending number, 2 equals to 103, and then I can say, all right, do this by whatever I'm incrementing by. So by equals 1.8 will be exactly what I want. So I can run that. You'll notice that in the values, I now have a vector that starts at 8 and almost goes all the way up to 103. It can't quite do that evenly here, but it goes up to 101.6. An additional 1.8 here would push that over 103, so that's why it doesn't quite go all the way up to 103. And the second part asks, using the length function combined with which, how many of the elements are larger than 90? All right, so which is a very useful command, but we won't talk about too much about it in this course. Basically what it does is it reports back the positions inside of a vector that meet a certain condition. So if I say which y larger than 90, what that it'll do is it'll say, okay, it looks like the 47, 48th, 49th, 50th, 51st, 52nd, and 53rd elements of y are bigger than 90. So I could actually extract those. 47 colon 53 is a shortcut for a vector that is 47, 48, 49, 50, etc. And I see that, yep, all these guys are bigger than 90. Now, how many are there? I could just count that manually. 1, 2, 3, 4, 5, 6, 7. But length will do that for me. Length, whatever I pass to it as an argument, is going to report back how many elements are inside that vector. So if I say length which y greater than 90, that's basically going to count up the number of elements inside y that are bigger than 90, which I saw was 7. All right, so save it, knit it, we're done, looks good. I definitely recommend you, instead knitting to an HTML, actually knitting to Word, because that way you can format it after the fact. So very often what you'll find is that graphs are too big, the spacing is slightly inconvenient, and if you knit to an HTML, that's about it. There's nothing you can really do with it. If you knit it to a Word, you can take out stuff that you don't really want, and typically that's what I like doing because I'm a big fan of keeping things nice and pretty here. So notice the comment is on a separate page. That's kind of annoying. So actually, maybe delete this one here. There we go. So you can go through and you can actually figure out what formatting you like the best and, turn it in that way. And so that's why I like knitting to Word instead of HTML. Sometimes it doesn't really play well with RStudio and Word don't really play well with each other, in which case it's fine to knit to HTML. But if you can, knitting to Word is a little bit better. All right, so still trying to format here. I'll figure this out afterwards. A little bit about the homework. Let me go to homework 1 here. Make sure to replace your name in your section with your name in your section here. Don't need to change anything else here. Don't need to change anything inside that first R chunk. Basically, you'll be doing just what you did for the activity. You'll define a variable x to be equal to 3 using the left-hand arrow notation, and then translating these expressions into R. Now, what do these expressions look like? Can't just look at it and then immediately figure that out. It's better to actually compile the document to see what's going on here. So a few hints: make sure that you have the implicit multiplication symbol. You're going to have to make sure to have a 0.1 times parentheses 16 minus 12, otherwise R will get confused. Make sure you have parentheses in the denominator here when evaluating that expression so that you get the right answer. Same tips for the rest of those. Be careful with your parentheses and with your implicit multiplication symbols. Question 2 actually deals with you converting an Excel file into a comma delimited file here. So let me actually open up Excel, and what I'm going to do is I'm going to open up the file for this homework assignment and just show you how to do this. So homework 1 is where the homework 1 click3.xls is on my computer. And to convert this into a comma delimited file, you're going to go to File and then Save As. And if you're on Windows, it's slightly different. But basically, you choose the format and choose something that looks like .csv here. And you'll save it. You'll ignore any sort of warnings that come up. It's always fine. And once that's done, assuming that that file you just saved and your RMD file are in the same place, you'll be ready to just read in that data file. So if I try to read it in, it says, nope, I can't find it. Why is that? Well, notice I'm still in my Activity 1 folder, So you should have everything in your BAS320, and that should be your default, so you should never have an issue here. But let me change into my homework 1 folder, and now this will let me scan that in just fine. So same sort of question, how many rows and columns? Show the first 4 lines with head. Head, then in parentheses, the name of the data frame, comma 4. We'll do that for you. Show rows 320 and 471 by basically doing the same thing we did last time, but instead of just a single number like 563, like what we did, we can get more than one row by making those two numbers a vector. So C, and then in parentheses, 320, 471. We'll end up doing that. So check that out. Looks great. It's a pretty long row here. Make sure to fill out that comment. Make a bar chart of the column device model. You'll be using plot to do that, and then also running table to just look at how often you see each of the possible values, each level. You'll make a relative frequency table, just basically converting a normal table into percents. There's an example in the notes to do that. And then you'll be doing 2 subsets. You'll be making 2 subsets, sub.s2 and sub.s4, which contain only rows where SiteID are s2 and s4 respectively. So because you're watching, I will actually go through this for you because this is kind of a stumper unless you have worked with it before. There are a few examples in the notes. But remember, since we are going to be naming and creating some new data frames here, we're going to give the things a name and then use the left-hand arrow symbol to accomplish this. And just like what we did for the activity, we're going to be using the subset command, but we got to make sure to get our syntax correct. So we called this data frame click to begin with. So we're going to take a subset of the click data frame. The second argument, right after the comma, tells us the conditions we want the rows to satisfy inside that subset. And in this case, we want only rows that are equal to SiteID being S2 for this data frame right here. So how do I do this? Well, SiteID equals S2. You might think that's the way to do it. Nope, not quite. If we're dealing with a logical condition like greater than, less than, equal, not equal, and we actually want to check to see if something is equal to something else, we actually need a double equal sign. Will this work? Nope, not quite. Because S2 needs to be treated as basically a text expression. If I leave it as is, R is going to think that S2 is a variable. It's going to try to look up what that is, and we'll get confused because that doesn't actually exist. So if I do S2 in quotes, basically what it's going to say is, all right, check out the click data frame, look at the SiteID column, look at the rows which are equal to or have the value S2 in them, basically the text expression S2, extract those and put them in the subset .s2 here. Notice I got this red X here, meaning that the way that I've written this command is not going to work. Why isn't going to work? Well, I have an extra double quote over here. I will delete that, and now I can run it, and it looks great. So did I accomplish that? If I look at the first 6 rows of sub.s2, you'll notice that the site ID for all these guys is s2. And in fact, if you looked at all the rows, it would be the same thing. All right, so getting the subset of S4, same sort of thing, just instead of S2, it's S4 here. All right, then what you're going to do is you're going to run a command that divides the number of clicks by the number of instances to get the fraction of users who actually click that ad. So, all right, doing some real analytics here, doing some good data analysis here. Here we have just for site ID 2 here. And if I did summary, or let me do a table actually, of this data frame $click, that'll tell me, how many people did and did not click that ad. I actually want the percentage, and I can easily calculate that just by hand. That's not hard to do. But I want to use R to do this for me automatically. So if table gives me the number that did not click and did click, I'm able to divide both those numbers by the total number of instances, total number of rows in that data frame, by doing nrow sub.s2. This, just by itself, tells me how many rows are in that data frame, 9,367, basically the sum of these two numbers. So notice when I do this, voila, I get that 80% did not and about 20% did. So I'll need to do that same calculation for the sub.s4 data frame and get my answer from there. And compare to see if there's a significant difference in the click-through rate between those two sites. All right, question 3 wants you to read in another data file, homework1-ops, and the command's there for you. You just pretty much have to uncomment it when you're ready to go. And my data file is in the correct folder, so it read it in just fine. Here's a whole bunch of, there's a ton of data in here. So many columns. And what you'll be doing is you'll be making a histogram of the column outcome M2. So how do we make a histogram? Hist. Then in parentheses, the thing we want to be making a histogram of. And in this case, the outcome M2 column of the OPS data frame. So OPS $, outcome M2 is going to make our histogram here. Great. All right, business analytics is filled with very skewed distributions. This is a useless histogram. It's awful. So what we're going to do is we're going to make a histogram of just the logarithms instead, log base 10. How can we do that? Well, super easy actually. It's still using the hist command, but instead of making a histogram of OPS $ outcome M2, what if I did log 10, and then in parentheses there, outcome $M2? Well, this will evaluate the log base 10s of all the numbers inside the outcome M2 column, and then make a histogram, and there we go. Much more pleasing histogram to look at. Okay, so that's part A. Part B says, all right, use the preferred histogram, obviously this one here. Comment on how many peaks you believe the distribution to have. So I talked a little bit about what a bona fide peak actually corresponds to. So use your best judgment. I'll give you a hint. This is not a peak right here. Part C says to make a box plot of the column Quan4. And how do we do a box plot? Well, pretty easy. Box plot, and then the name of the column that we want, OPS $Quan4. Notice I don't really give you a great hint right here. I say Quan3, but I really want Quan4. And what we're going to do is we're going to add a additional argument, horizontal equals true, so that it's horizontal instead of vertical. Without that argument, it would have been up and down like that. Just to show you that you can do it both ways here. All right, run summary on that column. So summary OPS $Quan4. You'll want to be putting all of this code up in here so that it's included in your output. Between what two values, at least approximately, do the central 50% of values fall? Well, hopefully you remember this from Stat 201. In between the first quantile and the third quantile, that's where 50% of the data falls. That's the top and the bottom of the box. So we see that between this number and this number right here are where the middle, central 50% of the data values are. All right, what's a typical value for Quan4? Well, the typical value is either the average or it's the median, depending on what the distribution looks like. The average is really only appropriate when the distribution is roughly symmetric. The median is more appropriate otherwise. If you have skewness, outliers, etc. Looking at this, I'm pretty sure you know which one to be using. So here's the median, here's the mean. You can just report which one is the most appropriate. All right. Part E, last question, of interest are products that have values of Quan1 less than 1 million. So make a subset containing rows that meet this condition. So you'll want to essentially uncomment this. You're going to name it subset. You're going to take the subset of OPS. What's the condition you want your rows to meet? Well, you want Quan1 to be less than 1 million. 1e6. Remember, E is short for times 10 to the. So 1e6 means 1 times 10 to the 6th power, or 1 million. That's great. All right, and then we're going to report the number of rows that need this condition, that meet this condition, and the number of missing values. So we can basically get all of that information by either doing nrow subset, that's the number of rows that meet that condition, or just looking at a summary of subset. Boop, boop. Oops, I actually got to run this command first. All right, so we had 210 rows. And this was a bad idea, doing summary just of all the subset. Let's do $Quan5 just to extract that particular column. And there we go. So everything is an A here. So 210, all 210 values are non-existent. So I'm sure I'm going to get a lot of emails about that, and I'm going to point you guys to looking at this little YouTube tutorial. So indeed, every single value of Quan5 in the subset does not exist for whatever reason. All right, so that is all I'm going to say here.